Double integral for e the power negative of x square plus y square dy dx. We need to change the Cartesian coordinates into the polar coordinates in positive quadrant. First, let's recall the remarks. For polar coordinates r theta, we write r with dr d theta. For spherical coordinates r theta phi, we write r square sine theta with dr d theta d phi. For cylindrical coordinates r phi z, we write r with dr d phi dz. So for polar coordinates and cylindrical coordinates, we write r as a determinant of the Jacobian. So the solution for the given integral. For polar coordinates, we know that we write x is equal to r cos theta and y is r sin theta. And x square plus y square, when we calculate, this comes out to be r square. Now as x is going to infinity and y is tending to infinity, r is tending to infinity, right? Which means if I draw a wedge, so this is your r, the distance from the origin. This r is tending to infinity. So the r is varying from 0 to infinity. And because they have asked the region for only the positive quadrant, so the value of theta varies from 0 to pi by 2. Right? So this is your given integral. Double integral e the power negative of x square plus y square dx dy. So the formula, just to change these Cartesian coordinates into the polar coordinates, and for that we write r with dr d theta, right? And writing this integrand in terms of r theta. And the limits for r is from 0 to infinity, and for theta it is from 0 to pi by 2. And this is e the power negative x square plus y square as calculated is r square. Right? So just now solve this integral. First, the innermost integral has to be solved. Putting r square equal to t, you get 2r dr is equal to dt, right? When r is 0, t is 0. When r is infinity, t is infinity. So the limits are same for t, and so just solving this from 0 to pi by 2, and this is from 0 to infinity. I need 2r dr in the numerator, so I'm just multiplying and divide by 2 to get 2r dr as dt. So this is e the power minus r square. Instead of r square, writing t into 2r dr as dt, and this 2 is also there in the denominator, and this is d theta. So this is 1 over 2, 0 to pi by 2, and the integration for this is e the power minus t over negative 1, limits from 0 to infinity d theta. Right? So this is equal to 1 over 2 integral 0 to pi by 2. Can I write this negative outside? Alright. So this is e the power minus infinity. This is 0 minus e the power 0 is 1 d theta. So this is minus 1 over 2. So the simple integration for d theta and this negative cancelled out with this. So it becomes positive. So this is equal to 1 by 2 theta, and the limits from 0 to pi by 2. And this is equal to 1 by 2 pi by 2 minus 0. So which is finally is pi over 4.